and Assalamualaikum. So today, me and my team will be presenting about paper chromatography using gel in pens. So before we start, let me introduce my group members. So the first one is Alisha Nur Ain binti Aminuddin, and next is Nurul Alia Masara binti Zulkifli, and next is me, Nurul Amir Shahida binti Aznan, and the last one is Nurul Najwa binti Isha.
In 1906, Michael Sweat used chromatography to separate plant pigments, which is a chlorophyll. He called the new technique chromatography because the result of the analysis was written in color along the length of the absorbent color. Chroma means color and graphene means to write. Chromatography is a crucial biophysical method that makes it possible to identify, separate, and purify a mixture's constituent parts for both qualitative and quantitative examination. The foundations of chromatography is the idea that mixtures of molecules applied to surface or solids, as well as fluid stationary phases, separate from one another while moving with the help of a mobile phase. The first objective is to separate the different pigments present in gel pen ink using paper chromatography. Second, identify the individual pigments based on their distinct travel patterns on the chromatograph. Next is to demonstrate the effectiveness of paper chromatography in analyzing mixtures. And the last one, identify the compositions of various gel pen colors. For the purpose, the first one is explore the chemical compositions of gel pen ink by separating their constituent pigments. The second one is reinforce the key concept in chemistry and analytical techniques. Next, provide insight into the complex formulations of everyday writing tools. Enhance understanding of how different pigments interact with the stationary and mobile phase. The last one is to illustrate the practical applications of chromatography in separating and analyzing mixtures. The advantage using gel in pen. The first one is cost effective. Paper chromatography is an affordable option for many applications since, as compared to other analytical techniques, the materials and equipment required are relatively cheap. Next is visualization. The evident separations of the inks components on the paper facilitates easy comparisons between samples and qualitative analysis. Third one is minimal sample requirement. When sample quantity is low, it is helpful that only a small amount of ink is required to complete the analysis. Disadvantage of using gel ink pens. The first one is resolution. The resolutions of paper chromatography is lower than that of more sophisticated methods such as high-performance liquid chromatography (HPLC). In complex combinations, it might not be able to separate every component completely. Next, environmental sensitivity. The results can be affected by variables such as temperature, humidity, and paper quality, which reduce their reproducibility in different settings. The last one is quantitative limitations. Paper chromatography is great for qualitative analysis, but because of its less sensitivity and precision, it is less appropriate for exact quantitative analysis.
So in this slide, I'm going to talk about a theory principle between mobile phase and stationary phase. So as you can see here in this slide, on the slide we have a mobile phase is moving faster than a stationary phase. Is it because in paper chromatography, the mobile phase moves faster than the stationary phase, facilitating the separation of anylates based on their differential interaction with the stationary phase and the mobile phase. The second one, in this slide, we can see the mobile phase is more soluble than the stationary phase. It is because in paper chromatography, the mobile phase solvent is indeed more soluble than the stationary phase paper. This solubility relationship is pivotal in facilitating the movement of analytes through the paper and achieving separation based on their differential interaction with the mobile phase and stationary phase. Other than that, we also conclude and describe the mobile phase as being more absorbable by the paper compared to the stationary phase. This distinction reflects the unique mechanism of separation in paper chromatography, where the absorbent paper facilitates the movement of analyte dissolved in the mobile phase. So the last point, differences between mobile phase and stationary phase is, in mobile phase, molecule that can move, and in stationary phase, the molecule can't move. So, in summary, in a paper chromatography, the mobile phase consists of solvent molecules that move through the paper and interact with the analyte present in the sample. These solvent molecules play a crucial role in facilitating the separation and identification of different components based on their differential interaction with the paper and the solvent.
Methodology. The materials and equipment that we use is, first, chromatographic paper. Next is gel pen in various colors such as red, blue, green and others. Next is ethanol, rulers, beaker and pencil. So that we need is to draw a line at the bottom of the chromatographic paper using a pencil and ruler. The line is known as a baseline. 2. We have to mark small X along the line and label each X with 1, 2, 3 and 4. To be marked each with X mark using a variety of pens, place a tiny spot on each X mark. Place the paper in the beaker containing the developing solvent such as ethanol, but make sure the level of the solvent is below the line. To allow the solvent to rest until about half distance and take out the paper from the beaker. After the paper has dried, measure all the distance and calculate the RF value for every ink.
Next, I'll be explaining the result of a paper chromatography experiment using gel ink pens. From the result, the solvent front reached 10 cm from the starting line. As the solvent moved, it separated the inks into their dye components based on their affinity to the solvent. As you can see, the red, blue and green inks did not separate, indicating that each of these inks contains a single dye component. However, the fourth sample, which is a multicolor ink, showed separation into multiple components, which is red and black pigment. Furthermore, the blue color traveled farthest with the mobile phase because blue color has higher solubility with the mobile phase and has a weaker attraction with the stationary phase. Also, it has stronger affinity with the mobile phase, allowing it to move more easily and travel a greater distance following red, green and black. Next, to quantify the observation, we need to calculate the RF value for each pigment. The RF value is the ratio of the distance traveled by the pigment to the distance traveled by the solvent. Before that, we need to find the distance traveled by the solvent, where we need to subtract 10 cm with 1.5 cm and then we'll get 8.5 cm. Moving on to the first color component, which is red. If a red pigment travels 7 cm while the solvent traveled 8.5 cm, the RF value would be 0.82. Following the blue color, 0.94, the green color 0.71, and the black color is 0.59. Thus, this experiment demonstrates the effectiveness of a paper chromatography and successfully separated the components of different gel ink pens. So in conclusion, paper chromatography is a powerful technique for analyzing the composition of gel ink pens. By separating the pigments, we can identify the different dyes used in the ink formulations. This technique is valuable in forensic science, art restoration, and quality control in manufacturing.